My resultant's right here. Yes? Mr. Grimm, I feel like I went left and then up. Well, you did. Good for you. Right? And then you came back to the right. Right? Correct? See. And then you went up. So total, you went up a lot, right? Because it's this up plus that up, right? And it looks like we ended up going more left than we did right, yes? Right? So it's going to be this amount here. I'm sorry, we more right than left.
Yeah.
That's what I meant. That didn't sound right. So I'm going to take this right and minus this left from it, yes? That's a piece of cake. So let's do the math on it. So it's 20 sine 30 goes here. 20 cosine 30 goes there. 15 cosine 70 goes here. 15 sine 70 goes here. And what do we get?
20 sine 30 is
20 sine is what? 10?
10.
And then
20.
cosine 30 is 17.3.
And down here?
15 cosine 70 is 5.1. And 15 sine 70 is 14.1.
So I went up 14, and then I went up 10 more. I went up 24 total. Right? And I went 5.1 this way, and I come back 17. That's 12.2, correct? Well, Mr. Groom, here's a classic question that a rookie would ask. Mr. Groom, I feel like I went up, and then I went over. Is it different? Is it wrong to draw it this way? No. Will the hypotenuse be the same in both instances? Yes. And what is it? A squared, B squared, C squared?
27.
27 point something-ish.
Oh, 27.0.
Oh, beautiful. It's the same on both of them. Now, Bella, question. This angle right here, how would I find it? How would I find this freaking computer would work ever? This angle right there, how would I find it? This one right here. Shh, that guy right there. How would I find it? Shh. So here's the deal. It's always inverse tangent. Always, always. Always, always. Who over who, dear? The way I've drawn this picture up right now. Who over whom? You need to jot this down. It's always opposite over adjacent. So in this case, it's going to be 24 over 12.2, right? What do we get?
63.2.
What?
63. 63-ish degrees. Okay. Yes, give me 7 or 8 decimal places if you're launching, say, an ICBM or something. If it's out here wandering around, you're trying to find your way back to your truck after you've been out hunting. As far as we're not traveling out in the woods, if you can't find your truck if you're within a couple hundred yards of it, you've got issues. Like literally have no sense of direction. You should be able to, and if you're like trying to get home, if you can't smell mama's cooking when you get within about 100 yards of home, well, you're not a teenage boy apparently. Okay, yeah.
What did you add again to the sides?
Well, again, I went up,
Yeah.
and I went up again. So I will add the two up pieces. So I'll add 14.1 plus 10, right here, right? Because they're both up. And then I had a left piece and a right piece. So since they're opposite directions, I minus them. And I always minus the bigger one from the bigger one minus little one, right? And since left was bigger, I ended up going left more. Okay? 12.2 more. Now wait, Mr. Grimm has a question. This person did it this way. This person did it this way. Do not touch your calculator. I will be pissed if you touch your calculator. What will this angle give me here? 27-ish. How do I know that? Because this angle and this angle have to add up to 90. If you people did it this way, you people did this piece of the triangle, yes? So if this is 27, this is 63. Which means, oh my gosh, they're alternate interiors. That means this one is 63. Oh, that's true, but there are also the other two angles of a right triangle that aren't the 91. Okay. And so they're complementary, and this is also 60 or 27 rather. Okay. You really cannot get lost in a right triangle. It's hard to get lost in a right triangle. I mean, you know, a pentagon maybe, I guess, but a right triangle, for God's sakes, come on. Maybe even a scalene triangle you could get lost in, but a right triangle, come on, that's dumb. Now, all right. Now, when we do navigation problems, as I drew this up the other day, which we probably won't have time to start on these today, but that's okay. We'll do a couple of examples today. Okay? I will say something to you like this. Jeannie, Mr. Grimm, you always use girl names. Why? Because I get tired of people saying to me, yay, we need to make sure we use all these inclusive names and so forth. I don't think it really matters what stick figure that I draw goes which direction to have a picnic or whatever. Okay, I just don't think it matters. But I just do it for a good time. I get bored. Jeannie walks 70 miles. That's a long ways. I know. Roll with it. At a compass heading of 120 degrees. How do I draw this picture? Well, Jeannie whips out her compass. And she goes, I'm going to go off on what? Where's 120 going to be? No, right here. And how do I know it's right there? Well, this is 90, Mr. Groom. You'd have to be an idiot not to know where 120 is. That would make this a 30-degree angle in here, would it not? Thank you. I know you're on it. Can you just... You're distracting other folks. So notice this person, somebody said, I think it was AJ said, that we went east. Well, we did go east. How far did we go east? I don't know. We can figure that out in a minute, yes? And we also went south, did we not? Now, I don't like the word southeast, because southeast means 45-degree angle. Half and half. Okay? Don't get all weird about it. We're just going down this general direction. But we went south and we went east a little bit. Okay? So this side here, of course, would be 70 cosine 30. And this side would be 70 sine 30. That's true. Right? What does that come out to be? Give me some numbers. Let's get some numbers.
Compass heading.
Oh, compass heading. Or compass bearing, if you prefer. Yeah. Compass heading. Thank you. What now?
60.6.
Which one? This one?
70 cosine 30.
And 35.
Yeah.
Okay. Now, is Jeannie going to be content to stay there? No. No. Then she goes 20 miles at a compass heading of 80 degrees. Now, where is she currently? Well, she's right here, Mr. Groom. So isn't her compass right here too? I highly recommend you draw it again. Is north still north? That's the funny thing about north. It's still north. And we're going to go off at an 80, like so. 80 is right there, correct? But I submit to you, Charlie, that 10 is right there too, is it not? So this time, she ended up going east again, did she not? But this time, she ended up going what? Just a skosh north. Now, I submit to you that she started here and she finished here, did she not? And look, she went east, and then she went east some more, did she not? And then she went south, and then she came back up north. In essence, she went mostly south, did she not? Nice. And if you know this side and this side, can you find a hypotenuse? Of course you can. Let's get some numbers, shall we? So I forgot what I said. So listen, watch. I'm just going to write them down. You play with me. So it's going to be 20 cosine 10, right?
20.
20 is the length.
No, 20, that's what it is. Or it's 19.87.
19.87. Oh, I got you. I got you. And 20 sine 10. What? 3.5. Mr. Grimm, if I had used 80 instead of 10, if you'd have used 80 instead of 10, these two numbers would have been the same, but backwards. Okay? But it doesn't matter. So, when we did this, we ended up going 19.87 there, yes? And then we came back north 3.5. I can't read your picture. Just deal with it. Just deal with it. Okay, now, here it is. So, we wrote this down somewhere, but now I can't see it. Oh, 35. So we went south 35, and then we went north 3.5. Where are we at currently? If we go down 35 and we come back up 3.5, we are south 31.5, I think. Whatever. And then look, we went this far and we went this far, both east. So if you plus those, you get 80.47. Correct? I think. I'm just going to roll with it.
Those dead pixels.
Yes? Do you see the triangle? Now, friends, can we find the hippopotamus? Of course. Do that, please, quickly. What is it?
37.4.
How much?
36.
This is no. This is 80 up on top, bro. So 80 squared plus 31 squared.
Is
86.4. What does that mean? That means she's 86.4 miles from where? From home, which is where we started, correct?
Yep.
Now, I'm just saying, if I'm at home and I went over to here, wouldn't it make sense to find this angle? Because if I want to know her direction from home, now, that would be inverse tangent of 31.5 over 80.47, correct? Which is? 21 degrees. Good enough for right now because I don't really care. Now, I'm going to redraw the picture down here just a skosh, okay? So, here's home. We are coming out this direction. What did we say? 80? What did I say? 80? How many? 86? 86 miles. Whatever. And we said this is 21 degrees, yes? But that's not a compass heading. What would our compass heading be? Well, Mr. Groom, I don't know. Well, I do. 0 to 90, right, is 90. Plus 21 is 111 degrees. That's from home. Now, wait, there's more. Mr. Groom, what if I'm here? What compass heading should I take to get home? Well, I feel like, wait for it, that's 180 degrees opposite. What is 180 degrees opposite of 111?
291.
291. That's to get him. This is from him. Now, Mr. Groom, wait, Mr. Groom. I see down here, this is 90, this is 180, this is 270. Are you saying that 21 is there and there? I didn't say it.
Do you smell burnt toast?
The backers.
No! Euclid said it. Blame Euclid. They are alternate interior angles. Yes? So that's 21. That's 21. Then 270 plus 21 is also 291. But if it's me, friends, I just find the first compass heading and then either add 180 or subtract 180 from it. How do I know which? Yo, your compass heading is between 0 and 360. If I minused, it would be negative. That doesn't make any sense, so add them. Okay? That's all there is to it. Now, on Friday, you're going to be given a sheet of paper. You're going to be going outside. Literally, it'll say something like this. Here's a tree. Walk from this tree over to this such's door. Well, that means I'll have a compass heading by using my phone. What do I measure it off by? I would use paces. Okay. This never fails, though. You always get the shortest person in the room working with the tallest person in the room. And because we are fair, we trade off paces. So this is what would happen. It'd be like 20 large person paces. And then the next person goes, oh, it's my turn. Like there's a drinking fountain or something where they walk, whatever. And then they're like, okay, now we're going to go from there down to so-and-so's room. And they get a compass heading from their phone, of course. And then like the little person will pace it off. And then when they go, how far is it from here to here? They're completely wrong. If you're going... Listen, if you are going to take turns, one person does all the pacing on the first problem. Then the next person can do on the next problem. It drives me bananas when they say, well, I did my paces, and then, oh, you're an idiot. Don't do that.
Oh, yeah. I'll take a step, and then you land with me, and you take a step.